Hello, and welcome to your file processing lecture. So far, everything that we've worked with has happened inside our actual Python script. We might import other modules to use them, but everything's happening in our script. However, we often want to bring in outside information in the form of text or data, and files are a great way to do that. Technically, a file is a group of information that permanently resides on the disk on your computer. There's all sorts of file types that you're probably familiar with. We'll mostly be working with text files and CSV files, but things like Microsoft Word documents, Excel files, those are all different types of files as well. So there's two main things that we might want to do with a file in Python. The first of those is reading the file. In other words, we want to get the information in the file and bring it in to our Python script. So remember, everything in Python is an object. So when you bring a file into Python, Python will store it as an object that you can then interact with. The open function is going to be really important when working with files. Basically, this function opens up a connection between our script and the file that we want to use. We'll go into detail about this a little more in a second, but this general schematic basically gives you an idea of how Python views us interacting with files. When we open a connection to a file, it basically creates a bridge represented by these arrows between your file that you want to read and the program that you're working in. If you open up a file to read, basically that says the information should only flow one way. We should open the file and read from the file to our Python program. In a bit, we'll also talk about writing, which is the opposite direction. That opens a connection where the information is expected to flow in the opposite way, from our program to a file. The syntax for actually opening a file in Python is to use this open function, which takes at least two arguments. The first argument is a file path to where your file is. So, for instance, if your file is in the same directory as your Python script, aka the same folder as your Python script, you can just say a string with the name of the file, dot, and the file extension. However, if your file is not in the same folder or directory as your Python script, you'll have to change your file path string to reflect that. Now, the second argument is telling Python how the connection should open. We just talked about a read connection, and the argument R for the second argument tells Python to open a read connection to that file. A W would mean a write connection. You can see that we can store this in the variable f. F is now our file object. And with this object, we can do a lot of things, including iterate through all of the lines in the document. For instance, in this case, we're going to open the file temp_txt.txt, and for each line, right, so that's one line, like when we have a new line, that will be the next line. For each line in the file object, we're going to print out that line. This object f is what we would consider an iterator, which means we can iterate, for example, with a for loop through this object. All right, so we're going to be working with files, so I just want to point out something really quickly. So my file processing 20 blank, which is what I'm working with, is in the same directory as the files that we're going to be using today, including this first one called gettysburg.txt. So that is what my path names are going to be, and if you'd like to follow along, you're going to need to download these files from GitHub and store them somewhere on your computer that you can access them. I would recommend putting them in the same file as whatever the document is, the Python document that you're following along with. All right, so let's go ahead and open that gettysburg.txt file. To open a connection to this file, we're going to have a variable that's going to store the file object, and we're going to use the open function. And remember, the open function takes two arguments, the name of the file or the file path, and then the mode that we want to open our file in. So I'm going to say gettysburg.txt. And remember, because the file is in the same folder, all I need to do is say the name of the file. If they were in different folders, you would have to modify your file path in order to reflect that. And then because we're going to be reading the file, we just want the information from the file to come into our Python script. We're going to open this in read mode. All right, now that we have an open connection, we can use it to grab the information from the file. So I'm going to go and iterate through the lines in the file and just print them out so we can see them. So I'm going to say for line in the object G, print line. And this is going to loop through all of the lines in the file gettysburg.txt and print them out for us. Let's go ahead and see what this looks like. Oh, but before we do that, one really important thing that we always want to do is remember to close our connection to our files once we're done with them. So since all I'm doing is looping through these and printing them out, I'm going to go ahead and say g.close. .close does not need any arguments to run, but what it does is it closes the connection between our script and the file. All right, let's go ahead and run this. All right, when we go ahead and run this, you can see that it printed out each line in the file. This file has one word per line and says 4 years ago our fathers. Let's go ahead and pull up the Gettysburg TXT file so that you can double check that this is what happened. All right, so here is our file, and you can see it did exactly what we wanted it to do. It read in each line of the file separately and printed it out for us. All right, let's try and open another file. I'm going to call this object G2, and I'm going to again say open, and then the name of the file. We'll say Gettysburg2.txt, and we'll open in read mode again. All right. Let's go ahead and see what happens when we run this. I'm going to save and then run. Oh no, we got an error. So what happened is the file gettysburg2.txt doesn't exist in the folder that I have. So Python, when a file doesn't exist, will throw a file not found error. This indicates to you that Python cannot find the file that you specified. Usually this means either there's a typo or maybe your file isn't located where you think it is. So we'll go ahead and comment this out because clearly it will never run. All right, so now we know how to read in files and loop through the text. Let's talk a little bit about how to write to a file. The last time that we worked with a file connection in Python, we opened it in R or read mode, but we can also open it in W or write mode. It's the same syntax in terms of the open function and the name of the file, but this time instead of R, we'll put W for the second argument. When you have a file open in the write mode, you can use the .write function in order to take data from your Python script and actually write it to your file. Again, when we're done, we always want to make sure to close the connection to our file. All right, so I'm going to go ahead and create an object called poem, and I'm going to use open, the name of a file. I'm going to call it my poem.txt, and I am going to open it in write mode. Now in write mode, Python will actually create this file for you if it doesn't already exist. If it does exist, then it will go ahead and overwrite that file. So make sure that if you're writing to a file, either it doesn't exist or it exists and you don't care about what's in it currently. Now that we have a writing connection open to this file, we can write lines to the file. For instance, in this case, I'm going to write some lines of a poem. So remember, we can say the name of the file object, .write, and then inside here put a string including whatever it is that we want to write to the file. Each time we call write like this, it'll write one line of the file. So I'm going to go ahead and copy and paste a couple of lines that I would like to write to this file. All right, as you can see, I am calling write 4 times, one for each line in the file that I would like to write to the file. Notice I have some text and then a new line indicating that I want an enter or a new line in this. So once we're done writing, of course, we want to remember to close our connection to the file, and we can again do that with the close function. All right, let's go ahead and run this and then open our mypoem.txt file and see what happened. All right, let's go ahead and run this and then open up our file. Okay, and on the screen you can see mypoem.txt and the 4 different lines that we wrote to our file. So below you can see that I am now writing a second verse for our poem. Now I'm going to open a connection to my poem.txt. I'm going to enter a new line because this is a new verse, and then write the following 4 lines to represent the second verse of our poem. Let's go ahead and run this and then see what the document looks like. All right, so you can see that our file did indeed write a new line and then the 4 lines in our second verse, but it doesn't have the first verse in there. And that goes back to what I was talking about earlier. When you open a connection, a write connection to the file, if that file already exists, which it did when we went ahead and did all of this, it will overwrite it, meaning that it'll get rid of everything we wrote to the file before and just rewrite it with all of this. If you ever want to append to a file instead of overwriting it when it exists, you can actually use something called an append connection. Instead of a W, we would put an A for the mode that we open the file in. Let's run this code now that this is in append. So we'll write this verse and then append this verse, and hopefully our file will now contain both verses. All right, and that's exactly what happened, as you can see. When we originally opened our file, we opened it in a write connection, it wrote the first verse, and then in the second time, we opened it with an append connection, which instead of overwriting a file if it already exists, we'll just add to that file, which is exactly what we did here when we added the second verse. So we've read files, we've written to files, and actually we can do both at the same time. For instance, in this code here, we've opened a connection to input and opened that in read mode. So we're going to be reading in information from the file input.txt. And we're going to be writing to, because we opened a file connection with a write in write mode, to output.txt. Basically, what this code is doing is adding line numbers to our text file. It opens all of the information in input.txt and loops through the lines, while keeping track of which line we're on. What it writes to output.txt is the line number plus a space plus the original line and then a new line. This will basically give us the same file back, but now with line numbers. Oops, and these 2 lines should be indented. Let's go to Atom, make that change, and see how this would work. All right, so now we have our input connection and our output connection in read and write mode, respectively. So let's go ahead and write that for loop, but with the correct indentation this time. So we're gonna say I equals 1, this keeps track of our line numbers, and we're gonna say for line in input, remember our input file, we're reading in the lines and looping through them. And we're going to say new string equals string I, so we're getting that line number, plus a space, plus the original line, plus a new line to indicate that we're like ending that line. Then to output, we're going to say output dot write new string. And then, of course, we're going to increment 1 so that we keep track of the line numbers accurately. All right, let's go ahead and comment out our old code and run this. All right, so you can see on the screen the input.txt file and the output.txt file. Basically, both of these look really similar. The only difference is this one is more spaced out and has those line numbers that we appended. The extra spaces are because of that new line, and the line numbers are because we added line numbers. And of course, one thing I should have done before we ran that is always close our file connections. So once we're done with them, input.close and output.close. All right, for this next part, we are going to read in the file myfile.txt, which you can see here on the screen. We're going to read through the file, we're going to clean it up a little bit, and then we're going to find all of the words that have all the vowels in that single word. And we're going to store them in a list so that we can see it. We're assuming that there is no punctuation in this file, which, as we can see when we look at it, is true. All right, so I'm going to go ahead and create a list called all the vowels. And this is going to basically store the words that have A, E, I, O, and U in it. And we're going to say with open the name of the file, which is myfile.txt. And remember, the reason why I can just say myfile.txt is because these files are in the same folder as my script. And then I'm going to open this with a read connection because I'm reading information in from that file. And then I'm going to say as f. Now this statement here, which you should have read about in your book, is basically equivalent to what we've been doing before, where we have a file that we read in and we store it in some variable. This with open is basically doing the same thing. It's saying open this file and store it in f so we can use it. So we're going to say, now that we have this open file connection, for line in f, which is our file object, line equals line dot split. And if we don't give it an argument, it's just going to split on spaces, so it'll give us each word individually. And then we're going to say for word in line, because remember we're going to have a list of all the individual words. And what we're going to do is check if all of the vowels are in there. Now there's some more elegant ways to do it, but here's how I'm going to do it for simplicity. If A in word dot lower and E in word dot lower and I in word dot lower and O in word, oops, not in that string, O in word dot lower and U in word dot lower. So if all those things are true, then it means all of the vowels A, E, I, O, and U are in there. We're going to say all the vowels dot append word. And then once our file is like completely looped through, we can go ahead and print out all the vowels so that we can see which of the words in our original document have all the vowels in it. All right, let's go ahead and run it. And we can see that from our original file, myfile.txt, there it is. The words that have all the vowels is unquestionably, abstemiously, cautious, facetious, facetiously, and effectuously. There we go. All right, so we went over a couple of modes that we can open a file in. We had read, write, and append. And I just want to put that in a list format and talk a little bit about what happens when the file doesn't exist or already does exist when you try and open a connection to it. So from this list, we're going to focus on the top 3 rows because those are the connections that we talked about. So when you open something in R mode, you're going to read only. For W or A, so write or append, you're going to only be able to write to the file. Now, if we try and open a file that already exists in read mode, that's good. We want the file to exist so we can read information from it. If the file doesn't exist that we try and open, as we saw earlier in Atom, it's going to give us a file not found error. So you want to make sure that you can check that your files actually exist before you try and open them in read mode. Now for write mode, it actually doesn't matter if the file exists or not, or at least it won't throw an error if it doesn't exist. If the file does exist, as we saw in write mode, the file will be overwritten. If it does not exist, then Python will simply create that new file for us and write to it. Append, on the other hand, will append data to a file if it already exists, and if it doesn't, then it behaves a lot like write mode, where it just creates the file and writes to it. All right, last but not least for files, I want to talk about CSV files. Now, you might be familiar with these as more like Excel spreadsheets, but CSV stands for comma separated value, and it's basically just a way to store data in a file. This is what a CSV file might look like if you opened it in a text editor. You can see that the different values in a line are separated by commas, and then the way that we know that we're moving from one row to the next is because there is a new line. That's basically how we read CSV files. Each new line is a row, and values within that row are separated by commas. But you might be more used to seeing CSVs, like when you open them in an Excel program, to look like this. And these two things have pretty much the same information, just a different way of displaying them. So even though we're used to things looking like this, we're going to be reading in our files like this when we read them into Python. In order to do this, we're going to be using the CSV package. So whenever we use this, we have to make sure that we're importing it before we use it. The CSV package works pretty similarly to what we've been doing with just writing TXT files. We're going to have a file path. We're going to open and put that file path as the first argument with the mode as the second argument. The next step is from the CSV package, and this is to say csv.reader that open file connection, and then the argument delimiter. Now, delimiter basically says, how do I tell where each value is within a row? We just said that in CSV, comma, separated value files, they're going to be separated by commas. So the delimiter is a comma. But you may have heard of things like a TSV file, which is a tab separated values. So sometimes this might be a different character. Once we have this object, we can loop through row by row this CSV object file. Okay, so what we have here is our import statement, which is very important to run before we actually need to use the CSV package. And then we have a file path that tells us where serial.csv is located on my computer. Again, if you're following along, you'll need to download this from GitHub and put it on your computer wherever you need to. Now, notice that my file path is very long this time. That's because this time my document is not in the same folder as the script that I'm running. That's why I have this path that's really long, because it specifies exactly where serial CSV is, as opposed to other times in the previous parts of this lecture where it was in the exact same folder. All right, so I'm going to go ahead and show you what this looks like in Atom. So this is exactly what we saw in the screenshot in the lecture slides. We have each row being a row of what we would think of in like an Excel file, and each value in that row is separated by a comma. So the first thing we have to do, which is the same as before, is open up a connection to the CSV file. So I'm going to say f equals open, and then CSV file path. And I'm going to open it in read mode because I just want to get information from the file, not write to the file. All right, so now we are going to use the CSV package. We're going to say CSV object equals CSV, the package, dot reader. And this function is basically built to read CSVs specifically. We're going to give it the open connection to our file, comma, delimiter, there we go, equals, and since this is a CSV file, it is separated values with commas, we're going to put a comma there. All right, so remember that this object is an iterator, which means it allows us to loop through all of the rows in this file. But I actually am going to go ahead and store those rows somewhere else so we can access them a bunch of different times. So I'm going to say CSV lists equals an empty list, and then I'm going to say for row in CSV object, so we're looping through the CSV reader object, CSV list dot append row. So this is going to basically loop through all the rows and append them to this list, CSV lists, and then we're going to be able to go ahead and use them. I'm also going to print out the row so you can kind of see what's happening as something iterates through the rows in a CSV file. All right, let's go ahead and run this. And you can see that it basically did what we said. It printed every single row. And you can see that each row comes in as a list with all of the different items now as individual objects inside that list. So for instance, name is its own string, then manufacturer, then type, then calories, etc. And then for the rows that actually contain the data, we have one object in the list per like cell that would be within that row. So now that we have all of these rows stored in CSV lists, let's go ahead and do something with it. So say I'm interested in the average calories in these cereals that are listed in this document. I'm going to go ahead and find out which index calories is at so I can figure out like which object to pull from each list, right? So I'm going to say cals equals CSV lists 0. So this is this header row right here because it's the item at 0 index. And I'm going to say dot index calories. Now obviously we could just count. I'm just showing you how to do this because sometimes we'll have bigger files that are not convenient to count. And so we're going to print out what is the index, and then we're going to go ahead and use that index to grab the calorie values from every single row. All right, so let's store the calories in this list calories. Okay, and then we're going to say for row in CSV lists, there we go, first, we're going to say if row bracket 0, so if the first item in that list or row equals name, so if it's this header row, continue, right? Because we don't actually have a calorie value in here, and so we want to skip it. So continue, there we go. And then else, we're going to do calories.append, so this is our list, and we're going to say row bracket cals, which, oops, there we go, tells us the index where the calories are located in each of our rows. And notice that Python thinks these are strings, so we're going to have to turn this into a float. So we're going to say float that number. Beautiful. So once we're done with this for loop, we should basically have the calorie values for every single row in this CSV file. And once we have that and we're done, we can say print sum of calories divided by len. Calories, there we go. And this is going to give us the average number of calories in each serving of the different cereals that are listed in our CSV file. All right, let's go ahead and run this. So you can see that calories is at index 3, which makes total sense. And the average number of calories per serving in all the cereals listed in the CSV is about 106.88 calories. All right, that is all I have for you. I will see you next time.